Hey everyone, thanks for tuning in to another video. So today we're going to be looking at Blazor components, aka Razor components, but more specifically we're going to be looking at how you can use Razor class libraries to share your UI code between a number of different projects. Whether those projects are Blazor Server, Blazor WebAssembly, or even ASP.NET Core. And we're going to cover off the basics of how to do that, and a couple of gotchas that you'll see later on. Now I want to clarify that we're not going to be covering the basics of getting started with Blazor or how to write components in Blazor. If you're not already familiar with Blazor, you're going to want to go check out whether you use Microsoft's official docs or any of the great tutorials that are out there on how to get started with Blazor, as we'll just be sort of diving straight into it. So, to look at what we're going to be doing today, we're going to start by creating a basic Blazor server project with a component in it, and then we're going to split that component out into a Razor class library that we can reuse in other projects, in other applications, and you'll see how we can then provide that as something that you can either share between the individual projects in your application, share to other teams within your organization, or even publish those components as a NuGet package or something else that you might want to provide to others who can use those sort of reusable pockets of UI logic. And remember that with Blazor components you can have UI logic and UI markup in the same component, so it's very easy to create a unit that you can easily share both to either to another project or to another user entirely. So to start with, you are going to want to have the Blazor components installed. Now one of the biggest ones that you'll need is the templates. Now the ones I'm installing, I already have these installed, but you're going to want to install the latest version of the Microsoft.ASP.NET Core.Blazor.Templates package. That will install both the Blazor Server and the Blazor WebAssembly templates. Now remember that as of .NET Core 3.1, only Blazor Server is supported in production. Blazor WebAssembly is still in preview. So once you've installed those templates, you'll gain new templates that you'll be able to find from the output of .NET New. So you'll be able to see here that we now have Blazor WebAssembly and Blazor Server available as templates. So, in this empty directory, we're going to quickly create a server application, very imaginatively named server, by simply running .NET New Blazor Server. Now you'll see that will scaffold out the standard Blazor Server application, including all the basics files you need to get started with, and not much more. So from that folder we should be able to pretty easily create some new components. So here you'll see opened up in VS Code that same server application, which includes the app.razor that we started with, and our imports.razor that controls all our imports. Now just remember for later steps, the namespace here, because we gave it the unimaginative name of server, the namespace is server. So let's start by creating a new component file, and let's think of a very simple reusable component, and that's a prompt to confirm or cancel an action. Whether that's a destructive action or not is UX concerns, not our issue, but it's a pattern you'll see very often, the simple here's some content, OK or cancel. So let's create our OK cancel .razor component. Now let's have a close look at this. This .razor file is essentially just Blazor. So at this point, there's no Razor class libraries involved, and we can simply create our code something like this. So this is just a basic div with the child content from the parent component or page, a button to confirm that we've already added an onClick attribute, which we'll have to define in our code, inside a div. That's pretty simple. Now, in our code block, let's add that onConfirm method there. So that will be an event callback that takes mouse event args. I don't need that. onConfirm. So I'll make that a property. Now, localizing that inside the component would not be particularly helpful, so we're going to add a parameter attribute so that the parent component can define what action occurs on confirmation. Now, that is the bare minimum. We do technically have a Blazor component, but this is an immensely unhelpful component. So let's also replace the OK here with a bindable parameter, OK text, and again, let's just add in a parameter This one is the very simple string, and we'll give it a default value so that if the parent component doesn't provide one, it simply says OK. While an OK is pretty helpful, you're often going to want to cancel things, so let's add in a cancel button as well. Now we'll use the exact same pattern we did for the OK button, but this time for a cancellation button. So we're going to grab these same two bindable parameters we're using for the OK button and provide them for cancelling. And cancel, and the cancel text that will default to cancel. Nice and simple. This means now that we should be able to, in our index.razor here, add a new OK cancel element. Now, before we go too far, we will have to set a new parameter of a render fragment type, which will allow us to set that child content to be whatever the parent component or page provides. So let's set child content. There's those brackets, those shouldn't be there. And we should now be able to run our new application. Wait for the restore and build to occur, and we should get Kestrel running with our Blazor server application. Now remember, this being Blazor server, it is not going to be using WebAssembly at all. It will be running over SignalR. So now that our server is running, we can have a look at what our page looks like. And we get hello world, including our new OK and cancel buttons. Nice and simple. Now that, however, is all just basic Blazor. What we're interested in is, can we take that component with our OK and cancel buttons and its very simple pattern and move that into a single core library that we can reuse in multiple applications. So if we jump back to our terminal and we make a new folder for our shared components. Now in shared components, we're going to run another .NET New, but this time for Razor class library. This will create a whole new project with a different set of pre-built scaffolded files than normal, including these component1.razor and example.js interop files that we don't need to worry about. So what does that look like in practice? Let's have a look in code. You'll be able to see our underscore imports.razor, which does exactly the same thing as it does in Blazor. We'll also see our new sample component, and you'll also find this www root folder. Now we'll come back to what this means and the implications, but this is where static assets go in a Razor class library. Now, like I said, we'll come back to that. What we want to do for now is take this OK cancel and move it into shared components, but still be able to use it in our Blazor server application. So what do we need to do for that? The basics is that we need to take this OK cancel Razor, move it into shared components, exactly as is, but now that application won't know where to find our OK cancel component, we need to jump back into our Blazor app and add a reference to our new class library. Now, since this is a separate library and a separate project, you will need to include it in your imports. So it's nice and easy as using shared components. Save that. Our index.razor still includes OK cancel, and our server CSproj now includes a project reference to our shared components library, which includes our all-important okcancel.razor. So, if we now run this again, we'll wait for it to do a full restore and build. We've lost our SignalR connection, as we expect, because we're still rebuilding. Now that it's back, let's reload and have a look. And look at that, we still have OK and cancel. Now these are the same this is the same OK cancel component as earlier, just now it's included in a Razor class library. So you'll see that OK cancel.razor is not included in our server application, it is in shared components. Now that's the basics of providing a Blazor component from a Razor class library, but all we've done now is made it slightly more complicated by having to include this extra library. Where this becomes important is that we can now include that in another completely unrelated project. So let's create a new Blazor WebAssembly project with .NET New Blazor WASM. This will create a client-side Blazor, i.e. Blazor WebAssembly application, and you'll see that it will scaffold out a Blazor client application that we can use to test our new shared components library. So let's collapse down server and have a look at client instead. We have the same normal client-side Blazor effects. Now what we're going to want to do first is add a reference. So the reference again is to our shared components project, and now we can add it to our imports in our client-side Blazor WebAssembly project using shared components. Now let's add to our index.razor, just above the survey prompt component, our new OKCancel component. If we close down our Blazor server application, switch to our Blazor client-side Blazor WebAssembly project, and run that, again we'll have to wait for the restore and build, but then from Firefox you can see that we can now switch into Blazor client-side, and we still have OKCancel, and that is the exact same component. If we were to, for example, change the component itself, we would simply change it once here in OKCancel.razor, and it would be effectively propagated out by any future builds of any consuming applications. Now, just from where we are now, we've already got a pretty great capability here. Our shared components project can contain any number of Razor components that any Blazor application in server or WebAssembly can easily consume on an opt-in basis to provide easy, ready-to-run components for any UX need that the shared components library might provide something for. Now, what we particularly want to be able to do here, however, is have components of a little bit more complexity than 2 buttons and a div. And for that, most of the time, you're going to need some static assets, i.e. some CSS or some JavaScript. Now, we're going to focus on CSS because it's a little bit simpler, as you'll see, but a lot of this applies to JavaScript just as well. So the important thing is that, like I mentioned earlier, there is this www-root folder. Now, this folder includes all of our static assets. Here's what it looks like in a Blazor application, and here's what it looks like in a Razor class library. Now, the www-root folder in a Razor class library is included in the compiled output of a Razor class library, so these files are available to consuming applications. But you'll see that we have in our styles.css this .myComponent. So we should be able to easily make this horrifying style appear in our new component by simply adding that as the class to our div. But you'll see that if we do this, and then run our client-side application again, we won't be able to see that same design change reflected. Instead, when we refresh this view, we'll see the OKCancel buttons exactly the same as they were before. Now, the reason for this is that myComponent class is not actually available in the consuming application, because while those www-root static assets are included in the compiled output, they are not automatically consumed by the client application. There's no reference to them. So if we switch back to our code, all we need to do is in our consuming application, go to our host page, something like index.html, and add an all-important extra element to the head that references our styles.css. Now we'll get back to this in just a second, but if we save this and have another look at our application, you'll see that if we now refresh it, we get this in all its garish, stripe, red-bordered horror. Now, the reason behind this is, if we go back and look at this link href, this URL is where the magic is. Razor class libraries provide their www-root static assets, these files here, at the URL _content / the assembly project name, the project name, in this case shared components, and then the direct file name under www-root. If we included this in a folder, we'd need to include that right here, or if we gave it a different name, we'd include it here. Worth noting also that this name uses NuGet package IDs if you're publishing this to a NuGet package. But this _content /shadecomponents/styles.css URL will correctly resolve to this styles.css page. So this is important because, like I mentioned, any static assets included in a Razor class library are available to a consuming application. They're not automatically referenced by those applications. So if you want to provide styles or JavaScript for your consuming projects, whether those are your own projects or potentially to third-party developers to use, you will need to provide instructions for referencing the CSS files that you've included in your package. This becomes particularly important, as we'll see in just a second, if you're intending on using third-party packages as part of your shared components library. So let's have a go at that. If we switch back to our shared components, this OKCancelRazor component, while it is perfectly functional, is not a particularly good-looking component. So what we want to do is, instead of using these plain HTML buttons, we're going to leverage the Material Blazor project. Now, to do that, we are going to need to add a package to our shared components. So we are going to add the Material Blazor package to our shared components library. Now, NuGet packages, like I said, are covered by the exact same restrictions. So Material Blazor provides all of its files as a Razor class library. We can now replace these boring HTML buttons with much fancier material button equivalents. I'm just going to quickly replace those. These details aren't particularly important other than that this is what Material Blazor uses as its button replacement. But, as we'll see in just a second, if we run this project, run our consuming application, our Blazor WebAssembly application, but if we see now, we'll note somewhat of a problem. These aren't materialified at all, and the reason behind it is the same reason that we didn't have this background appear earlier. The Material Blazor styles aren't included because they are part of the static assets provided as part of Material Blazor. So if we jump back to VS Code and open up our application, our Blazor client-side Blazor WebAssembly application, the same way we had to add the styles for our component library, we are going to have to add the styles for Material Blazor to our index.html host page. So you'll see from the project documentation that that is what's needed. And you'll note that, as we discussed before, the underscore content / the name of the package, and then the path inside it, is a simple reference to the Material Blazor styles. We can now rerun our Blazor WebAssembly project, and when we check again at the buttons provided by our component, they will be their new material equivalents to the boring HTML buttons from earlier. There they are, in all their material glory. So now we've got a solution to the problem, but we don't want to have to tell all of our consumers every time they use our shared components library that they'll also need to include all of our dependency static assets. So what we can do is use CSS itself to our benefit. So the static assets in our shared component library project at the moment is nothing other than that horrifying myComponent class. What we can do instead is use CSS to include the CSS that we're using from our dependencies. So if in our styles.css application we add an import from the URL that the Material Blazor project provides to its CSS, save that, we can now, in our consuming application, which remember you might not be the one writing, we can remove Material Blazor's reference, run it same as before, and you'll get to see that picking up the styles.css from our Razor class library will automatically include, thanks to that import directive, the styles from Material Blazor. And there we go. They're material equivalents, but remember, looking at the code, there's no Material Blazor references in our consuming application. All they need to know about is our shared component library. Now remember that the same thing will apply to JavaScript assets, and the answer to that's a bit more complicated than I want to get into in this video, so we'll have to look at that at another time. But for CSS, it's very simple to just use this /import directive to include style sheets that you use in your components. That way your consuming applications will only need to include one. Now to reiterate, the www root folder in the Razor class library project is included in the output of that class library for the consuming applications to make use of. But remember that those consuming applications might be just other projects in the solution you're working on, but they might be involved with other teams from your organization, or even from other developers if you're publishing your class library on NuGet. So you need to make sure that it's clear that while the static assets are made available to those applications, they do need to specifically reference them in the index.html for Blazor WebAssembly, or the CS_HTML equivalent in Blazor Server. So that's the basics of providing a component that you can use in both Blazor WebAssembly projects and Blazor Server projects, or in multiple of either. But not everything is using Blazor at this point, which means it would be really helpful if we could use these same Razor components, aka Blazor, in our ASP.NET Core projects, and thankfully that is possible. So we're going to create another project, a web project, that is just a basic ASP.NET Core MVC project, just from .NET New, and you'll see how we can still use our shared components library to include Razor UI in those projects, the same components we use in Blazor. So let's jump back to our code, and we'll be able to see how to do this. We're going to create another directory, and here we're going to create a new MVC project. This will obviously scaffold out a lot more components than our other projects will, as it is a full-on ASP.NET Core MVC project. We'll have to give it a minute to restore, and now we can open up that new application in VS Code. And here is all the basic defaults. Now, while it was pretty easy using Blazor to add Blazor components, there's a little bit more ceremony required for ASP.NET Core MVC projects, and that's because essentially what we're doing is not including the component directly, we're including Blazor in our MVC project, and then using that component directly from our Razor class library, but relying on an underlying Blazor that we've included in the project. So let's have a look at how to do that. First things first is we're going to need to add a reference to our shared components as we've had for the other projects. But if we simply add our okcancel.razor now, it's definitely not going to work, because there's a little bit of extra setup required. Most notably, we're going to have to add some code to our startup and program classes here. So during startup, when we're adding our controllers, we also need to add our server-side Blazor code. Remember that since Blazor server-side, Blazor Server, is a supported part of ASP.NET Core, it's already included out of the box, we don't need to do anything more to install it. We also need to map our Blazor Hub endpoints in our endpoint configuration down here. That's the simple case of endpoints.mapBlazorHub. Finally, in our program class, we need to add support for static web assets. And that's because, as we've covered, a lot of the Razor components functionality will be provided from static files, and without the ability to serve them correctly, the components won't render properly. So now that we've added those, now the process becomes pretty similar to what we were dealing with earlier. We need to add the view. We need to import the namespace for our shared components. We can do that in view imports, and then in one of our views, we can include our component. Now, unfortunately, we can't just simply do an okcancel, because ASP.NET Core MVC doesn't understand what that means. We do, however, have a tag helper that's able to render components for us, using the class name rather than the tag name. And it looks like this. So it is an async component, and it is simply html.renderComponentAsync. Here is where you include the class name of your component. It's in our shared components library called okcancel, and we're going to pre-render it on the server rather than relying on the client. Now, if we save that and run our new MVC web app, we'll see that it's built and running, and we can have a look at what that looks like in practice. Now you'll notice a familiar problem. We don't have styles, and that's because, again, we haven't included our static assets. Now, in MVC land, that becomes a simple case of including it in Vue Start. As a part of Vue Start, we're just going to include the style sheet that we referenced earlier, make sure the name of your URL is correct, save that, and if we now have a look at the page again, and we'll see that our component is rendered correctly with both the styles of the my-component class from our local to the class library styles.css file, as well as the styles from our material Blazor project, since we've included those CSS files in our class library styles. So that is rendering a component directly from our Razor class library in an ASP.NET Core MVC app. Now, if we make changes to our okcancel.razor component that we see here, so for example, let's remove that hideous background and border, and we rebuild our MVC app, we'll see pretty quickly that that style here should disappear since we've made the change in our shared components library, and as part of running our MVC app, it's rebuilt our Razor class library. Now that's all well and good, but the big gain to be had here is that if we now switch back to our original Blazor WebAssembly project and run that again, we'll see that we can use the exact same component that now doesn't have our myComponent style on it, and it's automatically picked up as part of running our Blazor WebAssembly project, and the same thing applies to Blazor server projects. Hopefully you'll be able to see how, using a Razor class library, you can create pockets of reusable Razor user interface code as part of your components that you can use in both your new Blazor server and Blazor WebAssembly projects, but also reuse in your older ASP.NET Core MVC applications. This way you can manage a single source of your UI, both markup and any limited UI logic you include in your components, that any other projects in your solution or in other teams or with other developers that you want are able to be centrally managed in that one Razor class library that you make available to consuming applications. Now, none of this is particularly new. We've looked at earlier the Material Blazor project. Most of those Blazor component libraries are provided as Razor class libraries, which is why they have the same limitations around static assets that ones you create yourself are. And I'd encourage you to go looking out there at some of the other Blazor component libraries you'll see, because there's some really great ones. Things like Material Blazor and Blazorize make it very easy to quickly create good looking interfaces in Blazor, and there's a ton of components for basically any need created both by small developers and some of the companies in the .NET community that make it a lot easier to quickly compose interfaces for your Blazor applications. But remember that you can also use those components in ASP.NET Core MVC applications if you're looking to transition towards Razor components in the future. You don't have to jump all in straight away. You are able to use Razor class libraries to centralize that logic. Now hopefully that was clear, and hopefully that gave you some good ideas on how you can use Razor class libraries in your projects to improve the organization of all of your UI markup and logic, and hopefully you found that helpful. Leave a comment down below if you have any questions or had any concerns around how we're doing things, and I'd love to hear suggestions for how we can improve running Blazor and Razor components applications in future. Thanks.